Hello, I'm David from Middleton Solar. This video is about our AST03 active solar tracker. First of all, I'll show you what's inside the tracker, then I'll show you how to set it up outside, and lastly I'll show you some of the accessories that are available for the tracker. Here are the components that make up the AST03 active solar tracker. We'll start off with the pan axle, which is the vertical axle. So the module for this consists of a stepper motor, 100:1 ratio harmonic gearbox, a stepper motor driver and a feedback position system. Now the tilt axis, which is the horizontal axis, consists of the identical module, pan axis, coupled to a passive module. This passive module does not have a motor of its own. It's coupled to this large motor here that drives both axes at once, both horizontal axes at once. And these three gearbox modules fit inside the tracker housing, and the housing is made from aluminium that's all welded together with mount bosses on the top, and this boss here is for connecting the control box, which we'll talk about later. There's a simple wiring loom that goes from each of these modules into the control box. This here is the active eye that's used, which I'll talk more about later, but it basically consists of a quadrant photodiode. Two of the quadrants are for the vertical positioning and two are for the horizontal positioning. The eye enables the tracker to lock onto the sun for real-time active tracking. Now, visible light does not actually reach the sensors in the eye, as you can see from this black window. The sensors react to a 10 nanometer bandwidth, which is a very narrow bandwidth in the near infrared. Now, transmission in this bandwidth is blocked by moisture in the atmosphere. Clouds of moisture. So any clouds near the sun will obscure any signal to the eye. This allows the eye to track the sun with great precision and not react to any false signals caused by brightness in the sky or brightness on the edge of clouds. When the sun isn't available, when it's obscured, the tracker immediately defaults to passive tracking, locking on using the GPS signal. Here I have the three modules assembled into the tracker gearbox, and I'm going to set up the actual position feedback and to test that the motors are functioning correctly. So I have a function generator here to generate the signal to drive the stepper motors. I have a power supply here, and I have a voltmeter here for the feedback of what's happening. So if I start the power supply up, you'll see how the voltmeter is counting up. It's about 2.4 volts at the moment. When it gets to the limit of travel, it'll stop the pan motor from turning. I'll stop it now. It's at 2.9 volts. And then we repeat the same setup test, but change the connections to the wiring loom for the tilt motor. So here we have the control computer mounted into the control box on top of the tracker gearbox, and we're going to download to it the firmware that's required to run the whole system. So you can see the firmware downloading now. It only takes a few seconds. I have the tracker indoors, mounted vertically on an optional levelling stand. And to the tilt axis I connect this stub axle, which has got a pin that must locate in that hole there in the end of the axle. I've already put a stub axle on the other end of the tilt with the eye mounted to it. Now if I turn the 12 volts on, the tracker will initially pan to point where it thinks north is, then it will tilt to be approximately horizontal. Then the GPS antenna will search for the GPS signal, get a lock on it, which it has now, and it will tilt and then pan to point where it actually thinks the sun is. And it's in the afternoon at the moment, about 3:30, so it's pointing over that way. Now this status indicator is indicating that the tracker is now tracking passively. Please follow the instructions in the user's guide supplied with your tracker. It shows step by step how to set it up. The tracker must be on a horizontal level platform. Here we've used the optional levelling stand with a bubble level to get the tracker exactly perpendicular. First of all, you blind the eye with a bit of aluminium foil so that it can't react to the sun. Then you connect a 12-volt supply and the tracker will pan to north and the eye will tilt to horizontal, and then the GPS will get a lock. The GPS lock can take a few minutes. It's now happened, and the unit will tilt and pan to point where it thinks the sun is. Now remember, the eye is still blind. Adjust the position of the tracker so that the diopter on the eye is centered. Use a spanner to adjust the pan position and a hex key to adjust the tilt of the eye. Now you remove the blind from the eye. Active tracking will start and the tracker from now onwards will be perfectly aligned with the sun. I have deliberately misaligned the tracker and blinded the eye so you can see the diopter is way off target. I'll now remove the blind from the eye and you'll see the active tracking happening to put the diopter spot on target. Here are some of the accessories for the AST03 active solar tracker. Currently it's mounted on a levelling stand, which is for portable installations. For permanent fixed installations, a levelling plate is available. This is the piheliometer mount for mounting a DN5 piheliometer. This is the shading arm assembly here. The pyrometer is mounted in this position for measuring diffuse radiation, and that's always shaded by that disc throughout the day. There's a position there for an unshaded pyrometer as well. This here is a pyrometer tilt mount for having a pyrometer that points always at the sun, like a piheliometer does. I'll now start the tracker up so you can see how the shading arm articulates. Here we have the complete tracking system mounted outdoors in this beautiful, clear, sunny day. So here's the piheliometer. This is the shaded pyrometer here, shaded by this here. You can see my hand shadow there if I do that. This piheliometer is measuring total global radiation, and this one here is following the sun just like the DN5.